Now we come to the session 37. In the previous slide, we already know the method of Newton's forward and backward interpolation formula and problems. In the Newton's interpolation formula, we are equal in this formula. We are equal intervals. So we are already know h should be equal interval, either 5, 10, or 1, like that. Is an equal interval. But in the Lagrange's interpolation formula, is we are finding unequal interval. See the interpolations with unequal intervals. The Newton's forward and backward interpolations formulae which were derived in the previous sections are applicable only when the values of x are given at equal intervals. In this section, we study the problems of interpolations when the values of the independent variable x are given at unequal interval. This is the main things. So in this x here in the x is an equal, means unequal intervals. In the Newton's Gregory formula, here is given the equal interval is equal interval, but the Lagrange's formula is not x is not an equal intervals. So not means is indeed you can find is unequal intervals. In this section, we study the problem of the interpolations when the values of the independent variable x are given at unequal intervals. See, the Lagrange's interpolation formula for unequal intervals. Let you take a function y equal to f of x, be a function which assume the values f of x naught, f of x1, f of x2, etc. So which assume the values f of x naught, f of x1, f of x2, etc. f of xn corresponding to the values of x equal to x naught, x1, x2, etc. xn, where the values of x are not equally spaced. Since n plus 1 values of the functions are given, the corresponding n plus 1 values of the independent variable x. See, this is the values depend on x, if x1, x2, etc. If we give values for 5 values, we get 5 values of the function. This is the way we say. If we give a 10 values for x, we get 10 values of the given functions. Like it. Since n plus 1 values of the functions are given, the corresponding to the n plus 1 values of the independent variable x. The starting from not x naught. That's the way. That we can represent the function y equal to f of x be a polynomial in x of degree n. Let it be polynomial b. Let the polynomial be f of x equal to a naught of x minus x1, x minus x2, etc. x minus xn plus a1 of x minus x naught, x minus x1, etc. x minus xn plus a2 of x minus x naught, x minus x1, x minus x3, etc. x minus xn plus etc. an of x minus x naught, x minus x1, etc. x minus xn minus 1. Call this equation as 1. Now, so each term in equation 1 being a product of n factors. So each term in the being 1 is a product of n factor in x of degree n. So put x equal to x naught in 1. Suddenly we get f of x naught equal to a naught of x naught minus x1, x naught minus x2, etc. x naught minus x. We can find so coefficients a naught. So a naught should be equal to f of x naught divided by x naught minus x1, x naught minus x1, x2, etc. x naught minus x. So put x minus x1 in 1 again. We get f of x1 equal to a1 of x1 minus x naught, x1 minus x2, etc. x1 minus xn. This implies a1 is equal to f of x1 divided by x1 minus x naught, x1 minus x2, etc. x1 minus xn. Similarly, we get replace x by x2, x by x3, x by xn, etc. in equation 1. We get a2 equal to f of x2 divided by x2 minus x naught, x2 minus x1, etc. x2 minus xn. Similarly, an equal to f of xn divided by xn minus x naught, xn minus x1, etc., xn minus xn minus 1. Substituting these values a naught, a1, etc., an in equation 1, we get y equal to the function, substituting for the function y equal to f of x equal to x minus x1, x minus x2, etc., x minus xn divided by x naught minus x1, x naught minus x2, etc., x naught minus xn into f of x naught plus x minus xn, x naught, x minus x2, etc., x minus xn divided by x1 minus x naught, x1 minus x2, etc., x1 minus xn into f of x1 plus etc. x minus x naught into x minus x1 into x minus xn minus 1 divided by xn minus x naught, xn minus x1, etc., xn minus xn minus 1 f of xn. Call this equation as 2. We observe in the equation, see, if f of x naught is not in the numerator, x naught appear, x minus x naught not here. The denominator, if you start from x naught minus x1, x naught minus x2, like that in f of x naught. Similarly, in f of x1 is not x minus x1 appear. So you observe the formula. This is the formula in the Lagrange's interpolation form. This suddenly we in this formula appear in the equation of formula 1 just for replacing x minus x1, x minus x naught, x minus x1, x minus x2 like that. So in this the second term you observe not appear x minus x1, but denominator start from x1 minus x naught, x1 minus x2, etc. in f of x1. Similarly, in the f of x2, yeah, x minus x naught, x minus x1 not appear for x minus x2 minus x, etc., x minus xn divided by starting from x2, x2 minus x naught, x2 minus x1, x2 minus x3, not x minus x2. Keep it in mind because product is 0 like that. So similarly, x minus x naught, x minus x1, etc., x minus xn minus 1 divided by xn minus x naught, xn minus x1, etc., xn minus xn minus 1 into f of x. So we clearly observe this formula in the Lagrange's formula. We come to the problem using the Lagrange's interpolation formula. Find f of 10 from the following data. See, we observe here in the data x is given x equal to 5, 6, 9, 11. Corresponding f of x is x for 5 is 12, for 6 13, for 9 is 14, for 11 is 16. So x is 5, 6, 9, 11. Corresponding f of x is 12, 13, 14, 16. We observe here is given. It's not equal interval. See the observe x 5, 6, 6, 9, 9, 11. So your difference is 1, 2, 3, 2, 1, 3, 2. So the corresponding values is also 12, 13, 14, 15, 12, 13, 14, 16 like that. See, so given data, you start from x0 is 5, x1 is 6, x2 is 9, x3 is 11. Corresponding f of x0 is 12, f of x1 is 13, f of x2 is 14, f of x3 is 16. Now you substitute Lagrange's formula. So f of x equal to x minus x1, x minus x2, x minus x3 divided by x0 minus f of x0 minus x1, x0 minus x2, x0 minus x3, f of x0 plus x minus x0, x minus x2, x minus x3 divided by x1 minus x0, x1 minus x2, x1 minus x3 into f of x1 plus x minus x0, x minus x1, x minus x3 divided by x2 minus x1, x0, x2 minus x1, x2 minus x3 into f of x2 plus x minus x0, x minus x1, x minus x2 divided by x3 minus x0, x3 minus x1, x3 minus x2 into f of x. Depend upon this interval. If you start from 0 to 4, there are 4 intervals given. So it's not starting from x0, x0, x1, x2, x3. The similar formula we are taking. Similar formula. We got depend upon the interval. There are 4 intervals. The 4 terms we are appear here. So x is substitute the values for x1, x2, x3 and x0. So we get x minus 6, x minus 9, x minus 11 divided by 5 minus 6, 5 minus 9, 5 minus 11 into f of x0 is 12, plus x minus 5, x minus 9, x minus 11 divided by 6 minus 5, 6 minus 9, 6 minus 11 into f of x1 is 13 plus 5 minus x minus 5, x minus 6, x minus 11 divided by 9 minus 5, 9 minus 6, 9 minus 11 into f of x2. Similarly, x minus 5 plus x minus 5, x minus 6, x minus 9 divided by x3 minus 5 means 11 minus 5, 11 minus 6, 11 minus 9 into f of x, substituting value. So here we want to find which value you want to find, f of 10. So x is 10. I replace x by 10. X by 10. So put x equal to 10. We get 4, 1, minus 1 divided by minus 1, minus 4, minus 6 into 12 plus 5, 1, minus 1 divided by 1, minus 3, minus 5 into 13 plus 5, 4, minus 1 divided by 4, 3, minus 12 into 14 plus 5, 4, 1 divided by 6, 3, 6, 5, 2 into 16. So simply we calculated the values, final values should be equal to 14.666666. So this is the value suddenly lies between 5 and 6. 5 and 6, 9 and 11. So suddenly these values should be lies between 9 and 11. 9 and 11. See, this is the values lies between 14 and 16. If the values lies between 9 and 11, the corresponding value that suddenly lies between 14 and 16. This is the value. So 14.6666. So similarly, we come to the one more problems. The similar same patterns, using the same patterns. Using the Lagrange's formula of the interpolations, find f of 6 from the following data: x equal to 3, 7, 9, 10. F of x is 168, 120, 72, 63. So by data, x0 is given, x1 is 7, x0 is 3, x1 is 7, x2 is 9, x3 is 10. Corresponding f of x is 168, 120, 72, 63. As of studying, f of x equal to x minus x1, x minus x2, x minus x3 divided by x0 minus x1, x0 minus x2, x0 minus x3 into f of x0 plus x minus x0, x minus x2, x minus x3 divided by x0, x1 minus x0, x1 minus x2, x1 minus x3 into f of x1 plus x minus x0, x minus x1, x minus x3 divided by x2 minus x0, x2 minus x1, x2 minus x3 into f of x2 plus x minus x0, x minus x1, x minus x2 divided by x3 minus x0, x3 minus x1, x3 minus x2 into f of x3. Substituting all the value, but x is given. Here x is 6. Replace x by 6. Corresponding values of x1, x0, x1, x2, x3. Substituting corresponding f of x is also given 168, 120, 120, 72, 60. Substituting all the values should be equal to see 6 minus 7, 6 minus 9, 6 minus 10 divided by 3 minus 7, 3 minus 9, 3 minus 10 into 168 plus 3 minus 6 minus 3, 6 minus 9, 6 minus 10 divided by 7 minus 3, 7 minus 9, 7 minus 10 into 120 plus 6 minus 3 into 6 minus 9, 7, 6 minus 10 divided by 9 minus 3, 9 minus 7, 9 minus 10 into 72 plus 6 minus 3 into 6 minus 7, 6 minus 9 divided by 10 minus 3, 10 minus 7, 10 minus 9 into 63. So totally we get 12 plus 180 minus 72 plus 27 is equal to 147. Certainly this value lies between 6 and 7. 6 1, 3 and 7. Certainly 168, 120. Certainly this value lies between 147 in this first beginning of the interval. So because it's not only this is the not necessary in between that, because unequal interval may be wherever in the tables. We come to the one more problem. Suppose it's not given the x values. The points should be in the order pair. So in the first, we already know using the Lagrange's interpolation formula, find a polynomial which passes through the point 0, minus 12, 1, 0, 3, 6, 4, 12. See, already now in the order pair, the first coordinate number denotes the length of the x-axis. The second coordinate number denotes the length of y. So suddenly yes. So what x is, if it is starting from naught, x0 is 0, x1 is 1, x2 is 3, x3 is 4. Similarly, the corresponding y0, y1, right? If y0 is f of x0 is minus 12, f of x1 is 0, f of x2 is 6, f of x3 is 12. So, by data is given. So, x0 is 0, x1 is 1, x2 is 3, x3 is 4. Corresponding values should be f of x0 is minus 12, f of x1 is 0, f of x2 is 6, f of x3 is 12. The substituting the Lagrange's formula for here f of x. So, x is not given. We want to express in the coordinate wise in the form of a polynomial. So, x minus x1, x minus x2, x minus x3 divided by x0 minus x1, x0 minus x2, x0 minus x3 into f of x0 plus x minus x1, x minus x0, x1, x minus x2, x minus x3 divided by x1 minus x0, x1 minus x2, x1 minus x3 into f of x1. So plus x minus x0, x minus x1, x minus x3 divided by x3 minus x0, x3 minus x1, x3 minus x2 plus into f of x2. Similarly, as substituting all this value, we get that. So x, so I'm substituting this, we get x cube minus 8x square plus 19x minus 12 divided by 12 into 12 because f of x0 is minus 12. So we get cancelled there plus x3 plus, so substituting the value, we get x3 minus 5x2 plus 4x divided by minus 6 into 6 plus x cube minus 4x square plus 3x divided by 12 into f of x3 is 12. So 12 get cancelled, 6 get cancelled, 12 get cancelled. Here minus sign. If you open that, we get, so simplifying the sum term x cube plus x cube minus x cube get cancelled. We get x cube. We get minus 8x square plus we get 5x square minus 4x square. We simplify, we get minus 12, 7x square plus 18x minus 12. This is the polynomial. So if we not given the value of x, we get it. So in terms of x, this is the polynomial. We are getting the polynomial in form.